Let's do this. Day 4. All right. Intro to logs today. Okay. Logarithms, or logs for short, okay, are inverses of exponential equations. So, as good practice for reviewing for our final, what do we do when we find an inverse?
Not the reciprocal.
Not the reciprocal. Inverses. It was chapter 6. Inverses. What do we do when we find an inverse? Chapter 6. 6.3. 6.4. What do we do? You got X, you got Y. What do you do with them? What? Not combine them. What do you do, Andrew? You flip them. You switch them. You switch them out. Okay? So we switch the X's and the Y's. Okay? So in an exponential equation, the domain of all of our exponential equations was all real numbers. Right? And the range was something along the lines of y is greater than 0, but then we adjusted that depending upon our equation. You know what I mean? If we shifted it horizontally, vertically, flipped it with a negative a value, etc. Okay? Well, now in a logarithmic equation, my domain is going to be x is greater than 0, and my range is going to be all real numbers. This is going to be helpful for us when we get to solving equations, which will be starting tomorrow. Okay? For those of you listening in on the interwebs, the sound you're hearing is our special guest today, Gracie. Gracie, come here. Come here, Gracie. Oh, nope, she's not interested in coming over here. Lindsay's probably crabby or something.
Yeah, she heard the rumor.
She heard the rumor? Okay. Now, here is something that you should memorize. Okay. You should memorize the fact that exponent equals log of base of the answer if and only if the base to an exponent equals an answer. So, this one over here, let me say that in a little bit different way. So this one over here, this is our exponential equation. We got a base, we got an exponent that equals some number. Okay? The logarithmic form of that very same equation looks like that. We take our exponent, and that's what we set it equal to. Then we write the word log. We know that it's a logarithmic equation because the word log is in the equation. Okay? When you see the word log, it's a logarithmic equation. Okay? Unless it's in an exponent. Okay? The base comes from the base of our exponent, and then the extra number is what I call the answer. Okay? Now, there are 3 conditions that go along with logarithmic equations. Okay? The first one is that b, our base, has to be greater than 0. But you already knew that. Okay? We've had that one already. The base can't be 1. Again, you already knew that. Okay? The new one is that our answer, what we're setting our equation equal to, has to be greater than or equal to 0. Okay? Right, Gracie? Exactly. You don't have to be scared. Get to know that. Math speak lesson. Okay? It's always good to learn how to speak math, because then you don't look like, a crazy person out there just talking whatever you want. Okay? Plus, I won't correct you then. Okay? So, how do we say that phrase? Well, we say this by, we start with the word log, and then we say the word base, and then what the base is. So in this case, it would be log base b, because that's our base, of x. Okay? Log base b of x. That's how we say it. Okay? Let's try some. Give me 2 numbers.
2 and 5.
2 and 5 I heard first. So, how do I say that? Log base 2 of 5. Okay? Log base 2 of 5. Give me 2 more numbers. Andrew, you said 7. That was one of them. Yeah. Give me another one. 14. Okay? So, how do I say that one? Log base 14 of 7. Okay? How do I say that one? Say what? No. No. What? No. 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 How I would say this one is I would say this one as it's not possible.
Oh, because it's well, no,
Because the answer part is negative, right? And that's got to be greater than or equal to 0. So if I were speaking it, I would speak it as log base 3 of negative 17 is not possible. Because it's not. Half there. You just didn't have the right part.
Right.
Yeah. We can rewrite these things in the different forms. So this right now is in logarithmic form, and I know that it's in logarithmic form because I see the word log. Okay. Out prominently in front. Okay. So in this particular one, my base is what? 3. My exponent is what? 5. And my answer is 243. So I put that all together, and I get 3 to the 5th power equals 243. You try the remaining 3. Second one, what do we got? 5 to the third power equals 125. Okay. Third one, 9 to the 0 power equals 1. Fourth one, 1/2 to the negative fourth power is equal to 16. And all of those are true statements. Okay? Just like all of the logarithmic forms are also all true statements. Okay? Those are all true statements. Okay? Now, let's go the other way. So now, my base here would be 3. My exponent is going to be 2. And my answer is going to be 9. So if I put that in logarithmic form, log base 3 of 9 equals 2. And both of those, 3 squared equals 9, true statement, and log base 3 of 9 equals 2 is a true statement. Okay? Try those 3. So this one in logarithmic form would be log base 2 of 32 is 5. This one would be log base 5 of 1 is 0. This one, I would first go 64 to the 1/3 power equals 4. And then I would say log base 64 of 4 is 1/3. What do logarithmics, what do logarithms do in math? What's their purpose? What do they give you? What do they find? They find the exponents. Yep. Logs find exponents. That's their whole purpose in math, is to find you exponents. Especially when the variable is in the exponent. Okay? When you have an exponential equation, we need to find that exponent. Logs is how we go about doing it. Okay? We can evaluate logs without a calculator. Okay? So basically what I'm saying here is log base 2 of 8, let's set that equal to something. Box, triangle, X, Y, whatever you want it to. Right? Gracie, we can set it equal to Gracie if we wanted to. Okay? Alright? So I need the exponent that I'm going to put onto 2 that gives me 8. What exponent do I put on 2 that gives me 8? A cubit. So that's 3, right? So log base 2 of 8 is equal to 3. Okay. You try those next 3. So if I put this equal to x, what exponent do I have to put on 7 to get me 1/7. -1. Yep. If I were to write this as 1/7, if I reciprocate that, that gives me a -1 power there. To the x equals 1/7 to the first. Then -x equals 1. So x would equal -1. Or if I wanted to go 7 to the x power equals 7 to the -1st power, again I'd have x equals -1. So log base 7 of 1/7 is equal to -1. Okay? One-third is 3 to the -1 power. 81 is 3 to the 4th power. So log base 1/3, oops, put my 8 in the wrong spot, of 81 is equal to -4. Log base 25 of 5 is equal to 1/2. Square root 25 and -5. Okay? There are two special kinds of logs out there. Okay? There's common logs and natural logs. Okay? So we will need a calculator to evaluate these because these can be evaluated on any calculator. Okay? It doesn't have to be a special kind of calculator. As long as it's scientific, it's got both common log and natural log on it. Common log is the log key on your calculator. Natural log is the ln key on your calculator. Okay? So, a common log is a log that has a base that is equal to 10. Okay? And so, rather than write log base 10 of x every single time, okay, they shortened that up, those crazy mathematicians, they shortened that up to just log of x. Okay? So if you just see the word log with no base, it's assumed that it's base 10. Okay? And that's what's on your scientific calculators, on your graphing calculators, on your, if you tip your phone to the side calculator. Okay, that's what all those are. So if we want to evaluate log of 13, and we say that, we just skip over the base part. We would just say log of x, and we're assuming then that it's base 10. If you wanted to add log base 10 of x, that's fine too, but we can just say it log of x. Okay? So if I want to evaluate log of 13, I would get 1.13943523068. We would probably only have to go out to 3 decimal places, but that's what it is. Now I can check this by saying ten, because that's my base, to the that big exponent, and that should equal what? But it should, if we round it, it's going to not be, but it should be 13. The more you round on it, the farther away from 13 it's going to be. Okay? So there's that one. The other one is something called a natural log. And a natural log has a base of e. So rather than write log of x, or log base e of x, okay? When I go to the Brewer games, I like to sit in the log level. Okay? They write instead natural log of x. And again, that should be a key on your calculator at somewhere. And when you type in the natural log, oops, let me clear that out. The natural log of 13, I get 2.564949,357,4615. And if I would take e to that power, I should get 13. Or if I round it, I should get something fairly close to 13. Okay? So, let's simplify some more equations. Okay? Again, I would set it equal to something, and then that something is going to be what my answer is. Now, my question to you is, in this first one, in number 15, which form am I in? Exponential or logarithmic? Log because I see the word log? Or exponential because the log is in the exponent spot? Which one? I think it's exponential, okay? Because the log, even though there is the word log there, and I told you earlier that when you see the word log, it's logarithmic form, the only time it's not is if that's in the exponent, okay? So this is in exponential form. So that means I have to switch it to logarithmic form. So log, what's my base going to be? My base is 10, right? Okay? So I don't have to write anything. If I wrote base 10, that's fine. Technically, it's kind of like not proper math, but I'm okay with it. Okay? Of, what's my answer? X in this case is equal to my exponent. What's my exponent? Log of 6. Okay? So in math, we've got to have equal parts, right? Okay? So I have log on both sides, right? With the same base on both sides, which means then that the other parts, the answer parts, have to be equal. So in this case, I would say x here has to equal 6. So 10 to the log of 6 power is just equal to 6. Okay? You try the other 3 while I go talk to our extras. All right, Freddie, you said you were stuck. Which one? 17? 16? No, 16. Okay? So if I set this one equal to, I can't set it equal to x because there's an x in the problem already. So let's set it equal to y. Right? Okay? Which kind of a form is it in? It's in a logarithmic form. Okay? So that means I got to switch it to exponential form. What's my base? My base is 3. What's my exponent? No. Y is my exponent in the logarithmic form. Okay? What's my answer? 9 to the x power. Right? What do I got to have? Equal bases, right? So this is going to be 3 to the y power equals 3 squared to the x power. So we get that. So that's going to be equal to, or y here is equal to 2x. So log base 3 of 9 to the x power is simply just 2x. Because that's what we've got y to be equal to. Okay. Next one. Again, can't set it equal to x because there's an x in the problem. So we'll set it equal to y. Then, what kind of a form is it in? Exponential, so I need to put it into logarithmic form. So if I put it in logarithmic form, then the natural log, or I should say, actually what I should say here is I should say log base e, right? Log base e is natural log of y is equal to the natural log of 3x, right? So y equals 3x. So e to the natural log of 3x is simply just 3x. I gotta move this stuff over. Hold on. it's in logarithmic form. So my base is e. My exponent is x. My answer is e. Oops, sorry, it's going to have to be y. Yep, I put x, but that should be y. Find my error I saw. So what's y got to be equal to? X over 2. So the natural log of e to the x over 2 power is just x over 2. Well, yeah. But they'll get more complicated when we add more stuff to them. You know, when we get to solving equations, we're going to build off of that. You know, we won't have it be equal to y. We're going to have it be equal to like 18. And then you'll solve for what x actually is. I know, me too. Hard. Yeah, it's hard. Okay, so this one's blue.